Okay, so again, this is another question, and sort of, I'm trying to try this without coming across too crass. I would put this question, this is maybe it's worth you knowing, sort of up for grabs. This is like in a sense the style of the question. So in terms of its difficulty level, this is at the easy to medium. Yes, the numbers are big and they're awkward and they've got scientific notation, but I'm asking for the centripetal force. So in this particular case, there's only one force acting on the moon. It's sort of like basically causing it to rotate around the Earth. So this in a sense, F net equals the FCP here. So maybe I didn't talk about centripetal force. Maybe that's confusing, but FCP is only one force. It's again, it's the force that causes the centripetal acceleration. Is mv squared over r. So in a case of where, again, just again talking about the previous slide, knowing that I can describe this as m 2 pi over t all to be squared times r. So in a case where you don't have to do any algebraic manipulation of the equation, where if I just insert the correct values, I get the right answer, I view that question as the easy to medium. So if I'm asking you for a quantity in which the quantity is the subject of the equation on the equation sheet, where I'm not asking you to basically manipulate the equation for a different variable, that's where I can see the question's up for grabs. And the challenge here, of course, is knowing your equations well, that I can write v squared over r as 2 pi squared over t, 2 pi over t all to be squared times r. And the only other challenge is like, how do you get days into seconds? And you're done. So this is, again, style of question. And I'm just being honest again, I'm not trying to be patronizing, just trying to be honest too. Like this question here, I can have all the values that are given, plug in the mass. Again, use parentheses. Whenever you use scientific notation on your calculators, do the calculation slowly. Don't do it all at once. I'd probably do the 2 pi over t, or maybe do the t first, then the 2 pi over t, then square all of that, then multiply by r, then multiply by m. Because if you ask your calculator to do too much, it will probably fail. Or maybe forget parentheses, and maybe it does the order of operations slightly incorrectly, and then you've lost all that time. You're better off maybe taking a little extra time with the calculations. So I'll leave it. The period is a little bit challenging, but 27.4 days. So 20.74 days. There are 24 hours in a day, and there are 3,600 seconds in an hour. So that's the hard part of the question, and then the other parts are just given in the problem. So to that, again, maybe I change my mind, but it's sort of definitely the medium. Maybe it's not say easy, but considering this in comparison to the force or to the friction problem, where you really have to do like a lot of like counting steps, like what direction the friction force. I got to decompose the weight vector force. Here, the only real calculation is the period, days to seconds, and then super careful. But that goes true for every question. But here, because you're doing a significant amount of calculations on your calculator, that's where I think possible errors could sneak in. So again, being really careful with your calculator, doing parts separately, you should end up with the choice C. So that's basically the gravitational force that's on the moon. So the thing that's causing the moon to rotate around in a circular fashion is the gravitational force. Not obviously non-contact, same as the way we go around the sun. We also have a centripetal force toward the sun. Here we have this force. Questions? Okay. So just